Hello everyone, my name is Priyanka and I welcome you all to my session. Let's read our question. It says that explain with the help of a labeled circuit diagram how will you find the resistance of a combination of three resistors of resistance R1, R2 and R3 joined in parallel. Also mention how will you connect the ammeter and the voltmeter in the circuit when measuring the current in the circuit and the potential difference across one of the three resistors of the combination. So first let us consider a parallel combination of three resistors R1, R2 and R3. So let's take three resistances here. So this is going to be our first resistor, the second one, and that's the third one. Let's connect them. Then let us just put a battery across them, and then we have a key and the further connectivity of the circuit. So let's name it. It is R1, R2 and then R3. So that's the EMF of the cell. That's the positive side, the negative side. That's the key. If you're saying that the total current flowing across it is I, so I1 is flowing across the first branch, I2 across the second and I3 across the third one, and of course I is coming out of the parallel combination. So an equivalent circuit can be drawn as like this. So this was the same key, this was E, our battery, positive, negative, and this we are telling is Rp, which is the equivalent of R1, R2 and R3 connected in parallel, and also the current flowing across them is I. Alright, so now sum of the currents across individual branches of a parallel circuit is equal to the net current drawn by the parallel combination circuit. Therefore, we can say that I is equal to I1 plus I2 plus I3. As voltage across each resistor is V, we can write the relationship for the current in different resistors R1, R2 and R3 as I1 is equal to V by R1, I2 can be written as V by R2 and I3 can be written as V by R3. So putting the value in the above equation, we can write it as I is equal to V common 1 by R1 plus 1 by R2 plus 1 by R3, and then let's name it as first equation. Now again consider a resistor Rp here, that is the equivalent circuit, across which if we apply same voltage V and the same current I is generated through Rp, then Rp will be equivalent resistance of this parallel combination of R1, R2 and R3. Therefore, using Ohm's law, we can say that V is equal to I into Rp, or I is equal to V upon Rp. So I'm naming it as second. So I'm going to compare the first and second, so we can get it as V upon Rp is equal to V upon 1 by R1 plus 1 by R2 plus 1 by R3. So cancelling these V's, we have got our formula for resistances in parallel, which is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that's the most important formula here to find out the equivalent resistance connected in parallel. Now, ammeter will always be connected in series to the resistor through which we wish to measure current, and voltmeter would be connected parallel to the resistor across which we measure the potential difference. I'll just repeat, ammeter is always connected in series because in series the current remains the same, and voltmeter is connected across parallel because in parallel circuit the potential remains the same. So it is always better to remember this concept really well. So thank you so much for your time. Have a great day. Bye bye.